Except number 7 was fun, wasn't it? Didn't you like doing number 7? Yeah, you did. No. Don't hide it. You see? Yeah, I knew. Okay. A 100 watt TV is powered by 220 volt. What's the current? So power equals IV. I equals P over V equals 100 over 220. So what's the I here? Let's hit that in on the calculator. 511. 0.4545. Okay? Next now. A electric heater draws 10 amps of current from 200 supply. What's the power? Power equals IV equals 10 times 200, which equals 2000. So 2 kilowatts. Is that okay too? Should be okay, I think, right? 3. A 2 ohm laptop uses a capacitor. It takes 2 seconds for the capacitor to discharge. So that means 5 tau equals 2. So tau equals 2 over 5. So RC equals 2 over 5. But the R is 2. So 2C equals 1 over 5. So C equals 1 over 5, which is 0.2 coulombs. So the capacitor is 200... What the fudge? My information is not consistent. Because I just said in the question it can hold a charge of 100. Right? Delete that. Pretend you didn't see that. Because it's inconsistent with the information I gave you earlier, and I didn't need to tell you it anyways. What do you mean, no? I can do what I want. It's my worksheet. How much energy is stored in the capacitor? Oh, did I tell you the voltage? Flip. Oh wait! Oh, sorry, Monica. Forgive me. I should believe you more, shouldn't I? Yeah. Sorry, Monica. The capacitance is 100 not coulombs, farads. Yeah, and we know the Q. The Q is 100 millicoulombs. Thank you. So, what formula can I say now? I can say C equals Q over V. So I can get V equals Q over C. Is that half a volt? Is that right? Half a volt? Q over C? Yeah. So then the energy stored is a half CV squared. That's a half times the capacitance, which is 0.2, times 0.5 squared. That's a quarter, that's an eighth. That's a fifth of an eighth. That's a 40th joules. 0.025 joules. I like that question. Whoever thought of that question. Yeah, good question. Great question. The best question. Okay, 4. A capacitor of 2000 millifarads of capacitance is fully charged and can perform 2 joules of work. If 2 such fully charged capacitors are discharging, then what is the voltage if they're connected in parallel and series? Okay, so let's do the parallel one first. Capacitor. They each have 2 joules in them of work they can do. So, and I know the capacitance. The capacitance is 2000 millifarads, or in other words, 2 farads. What would I like to know? I want the Q, I think. Q equals... no, I don't know the V. Okay, work equals a half CV squared. Do I know the work? Yes. Do I know the C? Yes. I would like the V. I suppose we can get the V out of this. Yeah, 2 equals a half times 2 times V squared. V is 1. And is it not root 2? Is it not root 2?
No.
Yeah.
Wait, capacitance in parallel is 4.
Oh yeah, but I'm just looking at one of them first. Yeah. So for one of them it's 1 volt, and for the other one, sorry, root 2 volt, root 2 volt. If you combine these together, if they're in parallel, what's the capacitance here? The capacitance. These add together to make 4 farads. Okay, now what's the work though? Is the work 2 joules or 4 joules in this picture? What is it? It's 4 joules. It's 4 joules. Well, there's 2 joules here and 2 joules here. It might not be. It could still be 2 joules. See, this is the problem. We know the charges. What's the relationship between the charges? Well, we know that the charges combine, don't we? It's the problem is when they're in series. If this has a charge of 1 coulomb and this has a charge of 1 coulomb, then what's the total charge? Not 2 coulomb, yeah, it's 1 coulomb. However, when they're in parallel, if this is 1 coulomb and this is 2 coulomb, 1 coulomb and 1 coulomb, this here will be 2 coulombs. I think this will be clearer if we use another formula. Do you remember the other formula for work? Work is a half QV. I think this would be more enlightening because we can see that the voltage here and here is the same. So that's okay. The Q here and here is the same, but when they come together, they add. So I think it is right and fine to add the work together to make 4 joules here. But I don't even really need to do that, because back here, when I worked out this is root 2 and this is root 2 volts, then I kind of know this has to be root 2 volts as well, because they're in parallel. So, what was my question? What's the voltage? I think for the first part it's root 2 volts. Now I wonder if I get the same answer if I look at this. So 4 equals a half 4. Oh, interesting. Yeah, it's the same. So yeah, it is the same. So it was enough just to look at the top one because they're the same. So root 2 volts is the first answer. 1.41 volts. And now what about the second one when they're in series? Now this is harder. Who knows? I don't know because I haven't done it yet. I just made this question up like a week ago. Let's see what happens. Okay, so capacitor, capacitor. Now this has 2 joules, this has 2 joules, but together I feel like it's still only 2 joules of work. You disagree? Because work is a half QV. The total work will be a half the total charge by the total voltage. So the voltage around all of this. This is actually the thing I'm looking for anyways. The total charge though, it's still just one of these, because when you put them together, the charge is in total is just for one of them. Yeah? So I think what I'll do is keep this as 2 joules. So I get now work is a half CV squared. Yeah. So work is 2, a half. What's the capacitance? Oh, we have to work that out. What is this? 2 farads? Yeah, 1/2 plus 1 over 2 is 1. So the total capacitance here is 1 farad. So that's a half times 1 times V squared. So the voltage here will be 2 volts. This is a very hard question. My goodness, Stephen, why did you make this so hard? Yeah? You got it, so why are you unhappy if you got the right answer?
I'm not unhappy because I use from Wednesday about
Are you still speaking?
yeah,
What are you saying?
I'm saying I use the same thing I use with AMS. Okay, it's because they are from the same.
Yeah, okay. Yeah, that was the thing that really made this difficult was, is it right to add the work or not add the work? And I think whether you can add or not depends on whether you can add the charge or not. Because remember, when we're talking about voltage and work, it's the charge that carries the work. Remember, 1 volt is 1 joule per coulomb. So if you can't combine the coulombs of charge, then you can't combine the work. So this is quite a difficult question. Let's go on to the next one now. 5. A flash camera does 5 joules of work in 100 milliseconds, and this is provided by a capacitor under 4 1.5 cells. Okay, so the voltage is 6 volts. The 5 tau is 100 milliseconds. So that means tau is 20 milliseconds. So the OR C is 0.02. Okay, now I'm looking for the OR, isn't it? So the OR is 0.02 over the C. Can I get the C? Well, I have work is a half CV squared. Do I know the work? I do. 5 is a half C36. So 5 over 18 is equal to C. Super. So now I have my OR. My OR is 0.02 over 5 over 18. So that's equal to 0.02 times 18 over 5. Let's work that out. That is 72 milliohms. You got that? Good job. Okay, next. 6. Anybody get 6? Did you get it right? Let's find out. 6. An electric car travels at a speed of 20 by means of a 5 kilonewton force. The battery is 276 volts. What is the resistance of the electric motor? Okay, so you have 2 formulas for power which are useful here. Power equals IV and power equals work over time. Right? Now, if I use this triangle VIR, I would like to replace the I, because in the question I don't mention the I. I do mention the V, and I want the OR. So, I can now say power is V squared over OR. Likewise, I can use the formula work is force by distance. I get power is force by distance over time. What's distance over time? Yeah, so that's FV.
Are they saying?
Yes. So voltage squared over resistance equals force by velocity. And what am I looking for? Resistance. So resistance is voltage squared over force by velocity. So 276 squared over 5,000 times 20. This 0.762. Yeah, you could look at this over a period of 1 second. That's fine too, because everything is constant here, a constant rate, I mean. Did you like that one? That I like. When I thought of this question, I'm like, I'm a genius.
What I'm doing is,
did you get the right answer?
yeah,
Okay.
W equals FA and then D equals DT and D.
What? W equals,
Force times distance.
yeah,
And distance equals to velocity times time.
yeah. And did you do what Monica did and looked at it for 1 second? Yeah, okay. Yeah, it's the same thing. Is that what you did as well? Yeah, okay. Let's look at 7 now. Okay. Let's add these together. Which ones to add first? Let's add the 0.75 and the 15. That makes 15.75. And then, now I won't bother writing micro. I'll do everything in micro, so we'll just remember that at the end. So 15.75 and 1 over that plus 1 over 1.5. That gives me the piece on the right. Yeah? Now I need to flip that, and that's in parallel with the 8. So I'll just add that straight with the 8. And then that's in parallel with the other 2, which I need to add, which I get by flipping around 1 over 5 plus 1 over 3.5. So I can do this all in one go on the calculator, hopefully. Minus 2. Oh, sorry. Sorry, I thought you were telling me the answer is minus 2. I didn't realize I typed minus 2. 1 over 5 plus 1 over 3.5. 1 over 15.75 plus 1 over 1.5, yeah? Okay. So that is a total capacitance of 11.428. Now what did I want though? I wanted the energy, which is a half CV squared. So this is 10 to the minus 6, that's the C, times a half, times the 9 squared, which is 81. And we shall do this in micro. So 463 microjoules. Okay, that wasn't as bad as I thought it could have been. 2 more left now.